crisis at the beginning of the 20th century, the problem caused by this crisis to philosophers of science. How do we provide knowledge with firmer grounds, with more solid foundations, and a number of different answers to this problem, a number of different solutions to this problem. Ludwig Wittgenstein's analysis of language, first of all, the logical positivists' criterion of verification based on Wittgenstein's work, saying that all scientific theories, only scientific theories that can be positively supported by experience can be regarded as scientific, and therefore as can belong to science and have a meaning for that. All other theories or propositions expressing those theories are not to be regarded as meaningful, and therefore have to be rejected and excluded from the realm of science. In close touch with logical positivists was Karl Popper in the early 30s of the 1930s. He was not a member of their group, but he developed his point of view, his idea of science, which actually sharply contrasted with that of logical positivists, but he developed that in close touch with them. And actually his book, Logik der Forschung, was published in the series edited by members of the Vienna Circle of logical positivists, namely the Schriften zur wissenschaftliche Weltauffassung. So what was Popper's answer to the problem that faced philosophers of science at the turn of the century? He said, the edifice of science needs not to be grounded in any way. Our knowledge can be reliable, we can advance our technologies, we can fly our planes, go to other planets, detect gravitational waves, but our knowledge is always and will always be a conjecture. We can never prove anything, we can never show the validity, or we can never verify, as the logical positivists originally said, any scientific theories. We can only test them. So Popper said it is crucial when playing the game of science, when doing science, it is crucial to abide by its rules. It is crucial to abide by a supreme rule or a higher rule, namely, we should not avoid any form of falsification. We should not design any ways by which a theory can survive a test that it actually failed. And so why? Because the content of a theory is the class of its potential falsifiers, as Popper said. So the number of predictions or consequences we may draw from the theory, which may actually clash with experience. If we have a clash, then we have to conclude that the theory is falsified. We have to revise our theory or replace it with something else. So the problem of the foundation of scientific knowledge was solved by Popper, but by cutting the problem of foundation at its very roots, by cutting the Gordian knot, so to say, of the foundation of knowledge, of episteme, at its very roots. So that our knowledge can be reliable, even if it cannot and it needs not be grounded in any way. This was in 1935. First half of the 20th century. It took some 25 years, a quarter of a century, for Popper's book Logik der Forschung to be translated into English, and the translation was actually published in 1959 under the title "The Logic of Scientific Discovery," the book I have here. In the meantime, a number of other developments within the philosophy of science took place, a number of really relevant developments at the time. So we see in the beginning with the early 1950s, a number of books and essays being published that actually challenged not only the original positivist point of view, but also Popper's own point of view. So much so that Popper's philosophy is often presented or often described as a boundary philosophy between two major revolutions in the 20th century philosophy of science. So not only a revolution in the sciences at the beginning of the century, at the turn of the century, but also two major revolutions, so to say, within the realm of the philosophy of science in the first half and second half of the 20th century. And indeed, we see from the first to the second half of the past century a shift in the consideration of experience within the discourse on scientific knowledge. Logical positivists saw experience as the place where theories can be verified, as they say. So theories find their positive support in experience. Then came Popper, and he said, no, theories can only be tested by experience. Science is not evidence-based, as it is often presented, but Popper says it is tested on evidence, not based on evidence. But evidence still played a major role. In the beginning with the 50s, the early 50s, in 1950s, a number of historians, philosophers, and themselves scientists began to challenge both these attitudes towards experience. So I list, offer a brief list of the major works that actually were printed beginning with the 50s. So in 1953, we have Stephen Toulmin, The Philosophy of Science and Introduction, which presents itself as a kind of textbook, introductory textbook to the then current debates in the philosophy of science, whereas it is in fact the actual presentation of new ideas in the field. Stephen Toulmin, who died a few years ago, was a major figure in this movement that later became to be known as the New Philosophy of Science. 1953. 1957, an American historian and physicist, whose name was Thomas Kuhn, published a series of lectures he gave in the history of science at Harvard. These lectures were addressed to scientists who wanted to have a background in the history of science, or else to non-scientists who wanted to have an introduction through history to the sciences themselves. So these lectures were eventually published by Kuhn in 1957 under the title The Copernican Revolution, which is once again a study in the history of science, but a study that presents already some of the key ideas that would later surface and become the key points, actually, the hinge points of Kuhn's major work in 1960. This was in 1957. In 1958, another major figure in the group, Norwood Russell Hanson, published Patterns of Discovery, and Michael Polanyi, Personal Knowledge. Another two major works followed in 1966 by another book by Polanyi, The Tacit Dimension. Then in 1959, Kuhn published a very famous paper called The Essential Tension, which would later be included in a book under the same title. So The Essential Tension is a collection of papers by Kuhn, but also the title of one of these papers, the papers included in the book. And I shall read a passage from this very important paper in a few minutes. Then in 1961, again, Stephen Toulmin published Foresight and Understanding, a book that actually presents issues and in a form and in a way that actually very much resembles what would happen the next year in 1962 in the works of Thomas Kuhn and Paul Feyerabend. And in fact, Kuhn always claimed that he actually preceded Kuhn, especially Kuhn, but also Feyerabend in some of their issues, in some of the ideas that they became famous for in just the next year. Anyway, the very storming of the Bastille, as it is often described, took place in 1962. So there was a gradual approaching to this famous date, 1962, in which so a number of years in which a number of important works were gradually published, but they all led up to two major works that actually mark the transition to the so-called new philosophy of science, so the historic turn in the philosophy of science in the 20th century. And these two works are Thomas Kuhn's famous The Structure of Scientific Revolutions and Paul Feyerabend's famous essay, not a book, but a famous article, which was later included in one of his books, Explanation, Reduction, and Empiricism. As you can see, the word empiricism recurs here because Feyerabend provides a critical understanding of the philosophical attitude towards empirical evidence. Anyway, let's focus for the moment. We shall come back to Feyerabend later on, but let's focus on what Kuhn says. Consider, for example, that any book in philosophy, when it gets published, it's usually published in 3,000 copies maximum. There is no great market for philosophical books. Kuhn's Structure of Scientific Revolution sold over 1 million copies in the original English language and was translated in some 24 languages, if I'm not mistaken, at least until a few years ago when I worked on that. Anyway, this gives you just a broad idea of the impact this book had, not only in philosophy of science, but also on other fields of research. So much that some of the terminology, some of the key terms Kuhn employed and introduced in the book, such as paradigm shift, incommensurability, and so on, have become part of our everyday language, even though people sometimes do not even know that they originated from Kuhn's work. Anyway, and these two books, two works, Thomas Kuhn's Structure of Scientific Revolutions and Feyerabend's Explanation, Reduction, and Empiricism, introduced for the first time, again in 1962, for the first time, the term incommensurability, which I just mentioned, namely the key notion that characterizes the so-called historic turn in the discourse on science.